You've cleared the coffee cups off your desk, closed 20 browser tabs, and put on noise-canceling headphones, but your brain still refuses to focus on the task in front of you. We usually blame ourselves for this kind of friction. We assume it's a lack of willpower, but you are likely ignoring a massive, invisible variable, the physical room you're sitting in. This represents human sensory intake. That tiny dot is your conscious attention, processing 50 bits per second. Beneath that, your autonomic nervous system is a supersonic jet, absorbing 11 million bits of spatial data from your environment every single second. Long before you register the paint color on the wall or the temperature of the air, your nervous system has processed millions of spatial data points and biologically altered your cognitive state. Out of those 11 million bits of data, one specific physical force dominates your mental performance within any given room. That force is the exact vertical distance between the top of your head and the ceiling. The physical height of a room is not merely an aesthetic design choice, but an active neurological trigger that tunes your subconscious state. A 2015 study led by researcher Ocean Vartanian revealed how the geometry of our surroundings functions as a silent governor for human cognition. Walking into a space with a low ceiling, your brain's surveillance system sends out a spatial radar, detecting the physical compression. That lowered volume acts as a biological blinder, limiting your visual field and concentrating your mental resources into a narrow, execution-oriented state. If you need to complete a highly detail-oriented task, like balancing an accounting ledger or executing precise data entry, sit in a space that physically prevents cognitive wandering. In these specific environments, physical spatial compression aligns our internal biology directly with the demands of meticulous mental work. Now imagine leaving that compressed office and stepping into a room with tall, vaulted ceilings. As the spatial volume expands in this diagram, your subconscious instantly measures the increased distance overhead. This expansiveness triggers a neural shift, pulling your brain out of detail mode and into abstraction, allowing your mind to link disparate ideas together. Complex team brainstorming sessions, developing broad marketing strategies, and abstract problem solving require these expansive physical volumes. Ultimately, expansive architecture biologically encourages cognitive expansiveness. You cannot trigger these states simply by looking at a photograph of a beautiful room. To engage these biological rules, our brains require a perception action loop, meaning we have to physically move through the architecture. Look at this photograph of the famous Ames room illusion. Due to forced perspective, the two men in opposite corners appear vastly different sizes. But this optical illusion only functions if you remain perfectly still. The moment you begin active exploration and step across the floor, your perception action loop kicks in, and the illusion instantly breaks. Architecture influences our mental state because your nervous system is constantly and actively measuring your moving physical body against the surrounding geometry. The spaces we inhabit are not neutral backdrops. They are highly active tools in our cognitive processes, constantly calibrating how we think and behave. If you are stuck trying to execute a meticulous task, stop trying to force a mental shift. Instead, move your body to a smaller, low-ceilinged room. And if you need to broaden your perspective and solve a complex problem, you must literally find a bigger room to stand in.